This video illustrates multiplication and division of rational expressions. As usual, it is helpful to review similar familiar concepts of fraction multiplication and division. Recall that to multiply fractions, we multiply the numerators and multiply the denominators. Fraction division is defined as multiplication by the reciprocal. To divide A over B by C over D, we multiply A over B by the reciprocal D over C. In working specific examples, remember that it is helpful to factor and cancel early in the process. To multiply 45 over 14 by 21 over 55, we will symbolically multiply the numerators and denominators in factored form. In the numerator, we write 45 equals 9 times 5, and write 21 equals 3 times 7. Similarly, in the denominator, we substitute 2 times 7 for 14, and 5 times 11 for 55. Now it's easy to see both 5 and 7 can cancel. We get a reduced 27 over 22 for a final answer. Now let's consider examples of multiplication with rational expressions. Simplify the product of 5x cubed over 4 with 2 over 5x. Again, we will symbolically multiply the numerators and denominators in factored form so that simplification is easy. In the numerator, we replace 5x cubed with 5x times x squared. In the denominator, we replace 4 with 2 times 2. Now we see that a factor of 5x and a factor of 2 can be canceled, producing x squared over 2. Now our irrational expressions have more than one term in the numerator and in the denominator. We proceed with multiplication as before, writing each numerator and denominator in factored form. We substitute x squared minus 3x minus 10 equals x minus 5 times x plus 2 in the numerator, and substitute x squared minus 10x plus 25 equals x minus 5 times x minus 5 in the denominator. One factor of x minus 5 cancels from the numerator and denominator. We're going to leave our final simplified answer in factored form to emphasize that no further simplification is possible. Even when the problems seem more complicated, the process is always the same. To multiply these two rational expressions, we again want to factor each polynomial and then cancel as much as possible. In the numerator, we replace 10x plus 20 with 10 times x plus 2, and we replace x squared minus 1 with x minus 1x plus 1. In the denominator, we write 2x squared minus 3x plus 1 in factored form, 2x minus 1 times x minus 1, and factor 5 out of 5x plus 10. Note that you may have to review factoring quadratic trinomials or work out the factorizations on scratch paper. But now we can see factors of 5, x plus 2, and x minus 1 will cancel. We get 2 times x plus 1 over 2x minus 1. However, in the original product, it was clear that x couldn't be -2, 1, or a half. In our final answer, it's still obvious that x cannot equal 1/2, but we made the other two restrictions invisible with our cancellations. Therefore, we should explicitly state that x cannot equal -2 or 1 in our simplified product. Now let's consider 3 examples of division of rational expressions. To divide by a rational expression, we multiply by its reciprocal. We'll get the first fraction times the reciprocal of the second one. We then multiply numerators and multiply denominators as before. If we do not factor and cancel before multiplication, then we have bigger quantities to factor and reduce afterwards. Let's consider a harder problem. First, note that division by a fraction means multiplication by its reciprocal. So we get the first fraction times the reciprocal of the second fraction. Now, instead of forging ahead with the multiplication of numerators and denominators, we will proceed with multiplication as before, writing each numerator and denominator in factored form. We substitute x minus 3 times x plus 3 for x squared minus 9 on top, and substitute 3 times 5 times x plus 1 for 15x plus 15 on the bottom. Now we recognize factors of 5 and x minus 3 can be canceled. Notice in our final answer we leave the numerator and denominator factored to illustrate that no further simplification is possible. Also, we should explicitly state that x cannot equal 3 since we can no longer infer that restriction from the reduced product. Let's consider one final example. In this example, I've color-coded the numerators and denominators to help clarify where I skip steps. To divide fractions, we multiply the first fraction by the reciprocal of the second one. This time, however, I factored each polynomial in the same step as using the definition of division. In the first fraction, we simply factored numerator and denominator. Then we've multiplied by the reciprocal of the second fraction in factored form. Notice that factors of x minus 3, x plus 1, and x plus 2 can all be canceled, leaving a simplified x over x minus 1 for our final answer. Again, we should really state explicitly that x cannot be -2, -1, or 3 in our final result.